Uh, so yeah, let's move on to the next question. So, is it possible to write a thesis without any professor when doing a bachelor's degree? I mean, how to write a paper and then publishing it alone or with a group of people, without interference from professor or something. So, uncle?
Yeah, one minute. So yeah, like help of professor is always better, but as I said, if you don't have any better option, like if you have produced something good and doing individual research project, then definitely no one cares about the home which you worked on. They'll just check your work or your way of doing research. And if you're submitting it anywhere, somehow, like let's say in any conference, so generally in research paper, you don't write about if you are professor or if you are undergrad. So you just write the name and the your affiliation. So you are just a researcher or scientist or any researcher, let's say. So they don't judge you, mm, they don't know anything about you. They just know about research work you did. So it's not really important. You can always do the individual research project, and then definitely you can, if you want to publish those in some journal, then you can definitely publish. But yeah, professorship is always needed, and sometimes funding is also needed. In that, if you are practical enough, so yeah, funding is also somehow compulsory. Yep, maybe Vaibhav can add more.
I'll just say, I think one point that we may have missed is that if you want to do experimental physics, of course, none of this is possible on your own, right?
Yeah.
That's a trivial example of not being able to do it by yourself, and that's just the nature of the field. And yeah, you don't have, again, it's the same thing that if you develop a skill or you write a document, even if it's not a novel result, just think of it as like developing your portfolio. You can still write a good document. You can even put it on, say, archive or put it on your website. And then whenever you're applying for a position or you want to show someone your work, you can. You just have a nice document. You can send them, here's a summary of my work. Here's what I did. Whether you publish or not unless it's a novel result, it's not the main thing. It's what skills you have and what work you have done. That would speak for itself.
Yep.
Okay. Let's move on to the next question, I guess. This was answered in a very good way, I guess. So, how to build your profile by third year such that when you apply for a B.tech BSc project under some other professor in a different university. For example, for someone who is doing in B.tech in mechanical or any other, and he wants to go into astro, there's an option to do his B.tech project at other institutes such as IIA or anywhere, IACR. So how should he build up his profile? And what are the what are the things that you should do to maximize his opportunity to get selected for them? Any one of you can,
Yeah, I think I can add to this. So, according to my experience, one of the safest option and skill you can learn in your bachelor's that will maximize your chances of being accepted by a prof is your coding skills. I think coding skills, which involves data analysis, data visualization, simulation, writing algorithms, and implementing them, and currently even machine learning and deep learning. And why I'm saying this is because if you are a bachelor and you are applying to a professor won't be expecting very deep knowledge about the subject or very deep knowledge in the field of research he is doing. Obviously, even if you have, he won't be interested in that. So many times these, as I said, sidekick skills will come to the rescue and will maximize your chances of being accepted. And I think from my experience in both the internships which I did at TAFR and IIT Pune, I was accepted not because of my physics skills. And I surely think that none of them even saw my skills in physics, but it was more of the tag which my branch gave, which was computer science, which made it possible to get accepted under them, because both of them wanted some student who can do some kind of coding stuff which was required in the project. In PA part, I was shifted to theoretical project. But yeah, mostly bachelor students are selected by professors to do some kind of simulation or some kind of coding work or data analysis work, which maybe they are not able to do because of lack of keeping up with the field. For example, Python is like mostly used now, and it may happen that some professors who is a theoretical physicist would have done some coding in their universities in, for example, say Fortran or C++, but he wanted to implement something related to his theoretical work. So he would be interested in taking bachelor's or B.tech level students under him to do such kind of things for them. And I think in bachelor's, that's enough to build your profile. As I said, it's more of how you are doing research under the professor. It does not really matter what quality of work you are doing, because in bachelor's, obviously everyone know that you cannot really do novel or original kind of research. So I think, yeah, this is one of the safest options which a B.tech or a BSc person can learn apart from main physics concepts. That will surely help him.
Yeah, as Fabio said, like those are the really good points, and most of the funded bachelor position in India are mostly biased towards good CGPA, and like if you see like Indian Academy of Science summer program and other program, you say, so generally if you are in a good academics and if you have some strong skills, computational skills, or maybe the short projects you can do in second year or first year, short maybe like a small workshop you can attend, or there are few refresher course or some short courses, like somehow like there, if you are interested in astro, so there are few short school or winter school kind of, you can try those. And yeah, this is how I think you can. And yeah, one of my experiences when I was in first year, I think, and I wrote to an IIT professor, and he was happy to have me with him. And like I was so obsessed with research thing, I wanna do research work and kind of I wanna do this. And he said, just chill and enjoy the learning and basic things. And like in first year and second year, just you can apply your to professors. So maybe there are few good opportunity in third year. So maybe first year and second year you can apply to write to some professors, not to do research project, just write. You will be self-funded in India. Like for 2 months, it's just 10,000 or 15,000 course. So I think you can bear that. So just apply for self-funded project, or you will learn something. So this is how I think you can increase your chance.
Okay. That was great, I guess. Vaibhav, do you want to add something to it, or shall I move on to the next question?
Yeah, you can move on. I think it's good.
How to publish papers on sources which are free of cost, and info about attending conferences. I mean, how one can attend the conferences, and what are the procedures to get your result to these conferences? Also, what are the open source sites or platforms that can host your results for free? So, do anyone want to shed some light onto this? Vaibhav, Uncle?
Yeah, well, archive is great. I think that's that's the best thing ever. If you have some document, if you think there's some research that you want to put out, archive is free. It's open source, and everyone reads it. As in, I think, yeah, pretty much every physicist reads archive, so it costs nothing. But it's not peer reviewed, of course, which is that your paper would be on archive, but it doesn't mean that it has gone through the process of peer reviewing and that any referees have looked at it. So that's the catch. But yeah, if your research, if any result is good enough, I think no one cares if it's on archive, whether it's published or not. I think it's sort of, yeah, that's not important unless you're looking for a job in academia. So yeah, just put it on archive. In terms of journals, it turns out that a lot of journals are actually free, and if you submit some work and it's good, they will publish it for free. So there's that option as well. But I think, usually at an undergrad level, if you think your work's good enough, you can just put it on archive. And about conferences, I think COVID was kind of a blessing in disguise, in the sense all conferences moved online, which means you could attend them or from anywhere. And usually for conference, you just submit an abstract that this is what you want to talk about. And unless the conference is really selective, you will get in, as in you will get a chance to, present your results. And the COVID helped in the sense that, you could just do it from your home anywhere in the world. But in the post-COVID world, you really can only attend conferences in your local area unless you want to travel. So that puts some constraint. But just find conferences that's happening in sort of either your country or close to your city. And usually, you just submit an abstract saying that, this is the research I want to present. And usually they just accept and you give a talk for 10 minutes.
Yeah, about the conference, I thought of, there are a few funding opportunities which you can apply for and attend international conference outside India. But those are really competitive, and being undergrad, you don't get that. So basically, you just find out nearby, or maybe in India, you can travel across a country and you can attend any conference post-COVID. So this is really fun, and you should try attending conferences. And the COVID thing going on. So basically, best part about conference is face-to-face interaction, and that is what you get to learn more thing. And archive is really great in terms of if you put any research papers on any other platform, let's say in your blog, suppose if you're writing any blog, suppose physics after engineering, suppose. So it was quite visited by others frequently. So Google code was working properly. So this was showing in just a first initial link, but others doesn't work like that. So archive work really great in terms of Google searching. So if you put some work there and if you search your work, so definitely it will show enough. So open source thing.
Okay, so apart from archive, what are the other, platforms that we should know about?
Publishing research paper, I think there are a few open source research publication. They publish free of cost, and there is one link I can just send it. Stranger provide the link or the recommendation for journals. You can submit your work there. So based on your abstract and based on your title, so you just enter your title and your abstract. So Springer, there's one Springer search engine, basically website you can use. So it provides you the best matched research journals where you can submit your work. So maybe I'll send it to you. So by just Googling those journals, their term and condition, rules and regulation, you just find out are these free of cost or not. So maybe this is how you can list out 5 to 6 research journals. In terms of impact factor also, you can just target 2-3 impact factor initially. If you got rejected, then improve it and submit to less impact factor journals. So this is how I think you can.
Okay. So let's move on to the last question, I guess. That's the last one. So what to do after you have finally published a paper? We have asked everything about how to do research and then how to write one. Then what to do? After when you have published a paper or a thesis, have written a thesis after PhD. So what is the process after that? How do we go beyond it?
It turns out physics is kind of like, marketing sometimes, that, once you publish a paper, very few people tend to read it, and you do have to promote it. So you have to very shamelessly go to conferences, promote your work, present your work as many places as you can. And so yeah, that promotion has to be there, and it is there. Everyone gives talks for that reason itself, that they want to promote their work and they want to say, look, I did this cool thing. Look at this result that I got. So yeah, there's that everyone does, and you have to do. And I guess the next thing is, often sometimes once you publish something, again, you learn so much that you get these new perspectives, that it spawns new problems, it spawns new questions. And I think usually a paper gives you a fair idea of, you can bounce off it and do a related thing. So I think that's one useful thing. But yeah, mostly it's a lot of promotion. So just go ahead and present your paper to, wherever you can, to anyone you can, basically.
Yeah, similar to like after any Bollywood movie, Kapil Sharma, so they'll come to promote their movie. So basically, yeah, publishing research papers and thesis is somehow part of your journey. And if you are into research, and then definitely these are some basics thing you have to do. And publishing research work, this is somehow journey, and you are building your profile. Suppose you're publishing your paper in MSc or B.tech or BSc, so you're building your profile for PhD. And if you're publishing your work during PhD work, then you're building for postdoc or your job, post-job. So basically building profile, enjoying journey. And yeah, like after publishing paper, you promote it and do more work.
So I guess we have finally gone through all the questions, and we are now on to the Q&A session. So here's the little memes for every one of you. So
There's one chat.
Yeah, so shall I take the questions, Devanshu? Hello. Yeah, I'll be reading out the questions. So first one is, to Vaibhav, it's pointed at. For being a good researcher, should we join ourselves with variety of topics, or to consider only one because we get the ideas that are linked with each other? So Vaibhav, would you like to?
Yeah, you don't have to, and certainly I guess most people usually stick to one topic, which is great. I think that's not a bad thing. But I think given an opportunity, I guess like in your master's something, even if you don't get into full scale a different research project, I think maybe at least in IIT there used to be a lot of courses with some short course projects. I think you can do that sort of a thing. I think it does expand your perspective if you do some stuff in a different field, even if it can be a short course project. It doesn't have to be a full-fledged research, but that gives you perspective that there's other kinds of physics, which is great, and there's other ideas floating around, and that can be helpful. And I guess if not, the cheapest way to do it is to just attend seminars. So don't just attend seminars from your own field, but just attend seminars from any field that you can, and that also again gives you a lot of perspective. So you don't just have to do research in a different topic. You can also just attend seminars and perhaps take courses.
And the next one is, which journal should one prefer when the research is just a little modified and upgradation of previous work, and that too on bachelor's level? Someone would like to answer that?
As I said, there are not a list of journals. So maybe depending upon your title and your work, you can just find out the list of journals and then decide upon the impact factor. So prefer less impact factor if you don't want to be demotivated. So maybe you can just send them your work, and definitely they are good research journals. They review your work and suggest you some good points also. So that is also helpful, like improving your work. So yeah.
And the next one would be how to avoid getting lost in literature while studying the problem, especially when there is no one to guide. This happens many times and often leads to losing time and no productive work. So how to keep focus on what to read and what not to?
Maybe Vaibhav?
Yeah. I think the way one advised way to read the papers is, you first try to get the big picture out of the paper. And, a good paper will have that either in the abstract, either in the conclusion, somewhere without even going into the paper. You should know what this paper claims to get, right? If it's an experimental paper, it should be clear this is the effect they found. If it's a theoretical paper, it should be clear this is the effect they think happens, right? So getting the big picture is important. Once you have that, I guess then you can decide, do you really want to spend time on a paper? And if it turns out, so many papers are actually badly written and, you just can't understand the thing. And that is fine. And then I guess it is fair to abandon those papers depending on how useful they are. But I think one key thing, at least that I do, is that for every paper, I just try to get first the big picture. What is exactly the result that they get? And then I decide whether to read it or not. And sometimes you even don't have to read it, right? If you get the big picture, often it's enough. So yeah, that's a judgment call, but definitely get the big picture.
Yeah, exactly. This is how it goes.
Someone would like to add something? Bhavya, uncle?
I think previous question, I've also mentioned you're just trying to build a kind of sphere around your main problem statement. So try to stick with your problem statement, learn from others, what they did and how they were gonna help with your problem. So this is how I think you can keep connected with others' work and with your problem statement. So getting lost will be having less chance by doing this practice.
Yes,
Yeah.
I think review papers can really come here, and it becomes very important. So if in whatever field you are interested in, review papers, try to search about review papers of that field, and review papers tend to give what Vaibhav said, tend to give this big picture of the field and where the directions are of the field and various other works which previously people have done in that. And most of the time the authors of these review papers are those who are professionally doing full-time research in that field. So they are particularly in that field doing research. So those kind of review papers are quite nice and really can give you a nice direction of where to look, what all literature to read and so on. I think, yeah.
Yeah. So moving on to the next one. Hello, and I have a question for all the panelists. What role their engineering degrees played in their research degrees? If they have a chance to go back, would they still pursue engineering? At least second part. The first part. I think that can be answered well because a mix of physics after engineering for someone being acquainted with both of research in both of the fields. I think that would give a nice experience working in that. What are your opinions on that? I think Uncle did quite some work with, which is a mix of engineering and physics, if I'm right. So,
sometimes you feel you did engineering, you spent 4 years, so maybe it's better to stick with your previous knowledge. Yeah, suppose if you are going for experimental work, so then definitely if you learn something basics, if you did, I am assuming that in engineering every course is having practical lessons, so definitely you learn something out of that. So maybe you can apply those knowledge out of doing experimental projects. So sometimes it helps, sometimes it's totally beyond your reach. If you're choosing doing theoretical physics, so definitely it won't help much. So maybe it depends on your choice. If you wanna stick to that engineering thing, if you feel less confident in shifting to other field, or if you are not feeling secure enough in your career, so maybe I can't say anything. I think it should be your choice to decide you wanna shift or not. So maybe I think. I think Vaibhav also shifted from engineering to physics, maybe.
Yeah, if you want to do physics, then clearly a physics degree is, the path of least resistance. Any other path is, just gonna give you more problems. Yeah, it's a no-brainer. But if you ended up in engineering, then of course, what can you do? Then you do have to switch, and you make use of whatever you can. But yeah, if in school you want to do physics, 100% do not do engineering. That would not be a smart decision, I think.
But in my case, it was the decision. Like from school itself, I knew that I wanna pursue physics, but like certain conditions, like I don't wanna do the 3-year physics BSc course. I wanna be in 4-year as your IIT. So this is how. And yeah, like sometimes it depends on the situation also, like financial situation, personal situation also, personal condition. So if you are doing engineering and personal financial situation is not good, then definitely you wanna go for job, 2-3 year job. So maybe still, if you are not convinced enough with engineering thing, then definitely you should try to sit there.
Yeah. So the question also asked if working in something that is that involves both engineering and physics. Has anyone tried that, or how does that work out?
So I think Dushyant, I can add to this one. So if you are in engineering and planning to do some physics research, then always you will not find in your university professors who can directly give you pure physics work. And so many a times what you tend to do is you tend to accept projects or try to do projects which has overlap between the field. And some of the engineering branches which has this overlap is first obviously is mechanical engineering. So you have this standard subject of fluid dynamics, which is in standard curriculum in mechanical engineering. And then what you can do is you can do research in fluid dynamics, and there is this field in turbulent fluid dynamics and phase transitions occurring in fluid dynamics. So what you are doing is you are entering the field from an engineering side, but you are drifting towards the more of theoretical stuff about the field, which it may happen that does not interest that engineering branch, but you are anyways doing it because you want to shift your interest to physics. Another possibility of doing research which has an overlap between engineering and physics is, I think, theoretical computer science. And with the coming up of deep learning, basically theoretical deep learning, more and more problems are in theoretical deep learning is being find or overlap with statistical physics. Okay, so there are a lot of papers which claim that neural network learning is done by phase transition. Now, phase transition is a purely physics-oriented subject. It's a purely subject which uses statistical field theory, and it's purely on physics side. And these kind of fields give you a way to learn about phase transitions and then apply to, let's say, neural networks. And so again, you have this overlap of engineering and physics, and you are trying to do a project which has this kind of overlap. So always try to find these kind of overlaps between your branch and whatever field you are interested in. For example, here physics, and you will find many interesting overlaps with your field. For example, biotech has this overlap from biophysics. So again, this basically gives you this kind of intuition. Even electrical engineering has overlap with physics. Many courses like systems, these are standard courses in engineering, has great overlap with basic quantum mechanical formulations, because both of them are literally same. They are like same. They are two different sides of the same coin. To be precise, Fourier series are occurring in signal systems and as well as occurring in quantum mechanics. So on. So I think you can find these kind of things. Obviously, you will have to do a lot of work about finding this overlap. But once you find this overlap, I think that's one of the options which you can opt for if you want to pursue physics and if you are currently in engineering, I think.
With respect to mechanical, I can suggest a few topics like, let's say, material science or low temperature physics. So right now, most of the mega science projects are based on low temperature and superconductivity. So if you study the fluid dynamics and low temperature cryogenic systems, so basically those are really helpful in building good and getting the best result out of these mega science project and applying it on like quantum systems. So there are a few fields in material science also, like building or developing high temperature superconducting materials. So, and even if you spend some time with engineering PhD students, you will see like those are also working in somehow physics areas. Like physics is what, like at PhD level, engineering students also working on a like kind of physics, but they are applying for different, like for designing turbulent pipe, for designing propulsion system, or designing different things. So physics is always with you, like even if you are doing engineering PhD or.
Yeah. So thanks, Uncle, and thanks, Dushan, for asking those questions. Sorry, guys. Due to the time crunch, we have the time limit of 8:30 only, and therefore, I would like to thank our panelists that have took their time apart, and then are here and being present in with of all of us, and also the attendees. And with that, we would like to end the meeting. But yeah, not the least, for the questions and the doubts that you all have, you can join our COS Telegram group as well as Physics After Engineering. Yeah, Dushyant has shared the links. With that, thank you, panelists. It was very great to hear from all you all, and thanks, attendees. And now, bye bye.
Yeah, thank you.
It's great.